All right, principles of microeconomics, example question with price elasticity of demand. So on an exam, right, you'll be given a little scenario. Doesn't really matter what the story is. It's the numbers that we're going to need, right? But for the sake of our example, let's imagine we have a local newspaper increasing the monthly price of their subscription from $15 to $20 per month. As a consequence, the law of demand, they lose consumers. The number of sales decreases from $10,000 to $9,000. So given that setup, the follow-up question, we want to be able to use the midpoint formula to calculate our PED, our price elasticity of demand. So A, know the formula. B, bring a calculator when you've got a test on this type of material. And then once we have that number calculated, right, be able to use it in a sentence, be able to give an interpretation of what that value means. So let's take a look. The question didn't actually ask you in this case to sketch out the demand curve, but I always think it's a good idea to visualize what's happening with our prices and quantities. So in this case, we're only given 2 points on the demand curve, but imagining it's linear for the remainder, we have our 0.1 and our 0.2. Again, so we're starting our original price, call it P1, $15, goes up to our new price, P2 of 20. Right, so we're moving up along that demand curve, and our quantity goes from its original, right, call it Q1 or QD1, 10,000, up along the demand curve, down to its new point, 9,000, we'll call that QD2. So those are going to be the inputs that we're going to use for our midpoint elasticity formula. And as long as you know what that formula is and you know what the combinations of points are, you're going to be in good shape. Right? So remember, our elasticity, by definition, it's the ratio of those percentage changes, giving us a measure of how sensitive the quantity demanded is to price. So for every 1% change in price, this ratio will give us the percent reaction in quantity demanded. But our job here is to actually calculate those percentage changes using that specific midpoint formula approach. And again, the whole point of that is to give us a measure that's independent of the direction of the change, right? So we don't need to know if it started at a price of 15 and went up to 20, or started at 20 and went down to 15. By using the midpoint or the average of those 2 points as the base for the purposes of our percentage change, we'll get the same answer either way. But it's that kind of wrinkle added to the percent change calculation that gives the midpoint formula that kind of complicated look to it. But again, that's all it is that we're doing. So like we said, once we've figured out, right, the position on the demand curve, we've got all the ingredients to our formula here. So the top part of that numerator, right, QD2 minus QD1, so that's just the change in quantity demanded over the midpoint, the average of those 2 points. And then from P2 to P1, the change in price over the midpoint of the original and the new. So with our numbers, right, maybe it's easier to start on the bottom, right? The price went from 15 up to 20. So P2 minus P1, 20 minus 15 over the midpoint between the two, which again, we can do a lot of this in our head, but just to nail it down, plugging everything into the formula, and then the reaction, the change in the quantity from 10,000 down to 9,000 divided by the midpoint between the two. And then note also that we're putting all of this kind of by convention in that absolute value operator, right? So even though the ratio here is going to be a negative number, because when price goes up, quantity goes down, and vice versa, right? The sign of the numerator and denominator are always going to be the opposite. By convention, we report it as a positive number. So that's, again, that other complication is really not that complicated. It's just basically saying, once we get our calculation, you can ignore that negative sign. All right, so now we're just plugging numbers into our calculator and simplifying our fraction here. So again, it's the 1,000 unit change over the midpoint between the two, the starting and the end quantities, between 9,000 and 10,000, so over 9,500. And then the percentage change in price, a $5 change over a midpoint base of 17.5, plug that in our calculator, and we get the numerator, change in quantity, 0.105. Basically, we'd call that a 10.5% change. That is the reaction to the change in price of a value 0.286 or 28.6% change, but we want the ratio of the two, right? So that comes out to be 0.368, which for interpretation purposes, the first that we notice is that's a number less than 1. So that means our demand for this product, we can say, is inelastic. The percent change in quantity is smaller than the percent change in price, giving us that ratio less than 1. And then kind of the final step, like we said, be able to use this number in a sentence, right? And again, we can think of this as that ratio, the change in quantity due to a change in price. So a 1% increase in price, for example, would be associated with a decrease in quantity demanded of 0.368%, less than 1%. Right? So that's all there is to it for the calculation. You might see, a more sophisticated, more interesting story to set this up. But once you have the numbers, it's always going to come out the same way. So hopefully that was helpful, and we will see you next time. Thanks.